Part A, Problem A4. A tape recorder playing a single tone of frequency F0 is dropped from rest at height h. You stand directly underneath the tape recorder and measure the frequency observed as a function of time. Here t equals 0 seconds is the time at which the tape recorder was dropped. The acceleration due to gravity is g equal 9.8 meters per second square, and the speed of sound in air is 340 meters per second. Ignore air resistance. You might need to use the Doppler shift formula for so-called motion of source and the observers in still air. This is the formula, where F0 is the emitted frequency as determined by the source, F is the frequency as detected by the observer, and V sound, V source and V observer are the speed of sound in air, the speed of source, and the speed of the observer. The positive and negative signs are dependent upon the relative directions of the motions of the source and the observer. Questions. A. Determine the frequency measured on the ground at time t in terms of F0, G, H, and V sound. Consider only the case where the falling tape recorder doesn't exceed the speed of sound. B. Verify graphically that your result is consistent with the provided data. C. What numerically is the frequency played by the tape recorder? D. From what height h was the tape recorder dropped? Solution. First of all, we cannot use a directly Doppler effect here because the source moving with a not constant speed. The speed is always increasing, and it means that in time t we are catching sound which are coming from source emitted in time t prime. And in that case we can use formula total height equal total distance traveled by source, which is 1/2 g t prime square, plus distance traveled by sound after that, which is v sound multiplied by t minus t prime. So we have to solve this quadratic equation. Let's rewrite it in better form. And now solution will be for t prime, this one. We see that we have two roots, plus and minus. Let's see what happened. For example, we have to investigate if t prime is correct for plus or minus. Let's take a look at this table. After time t equal only 2 seconds, the sound already reached us, and for this time source travel just a very small, very short distance. So it means that our building almost like about more than about 600 meters tall. And look at this formula. Here we have v sound square plus this 2gh minus 2g v sound t. So for time v sound t, this sound travel always almost height h. It means that here we have negative expression. So we have v sound square minus something very small negative. So it means that we have to subtract from v sound this part which is a little less than v sound. In that case v prime will be small, which is consistent, because it must be small. But if we put here positive, that will be 2v sound over g, which is quite big. So it cannot be right. So the correct root will be with negative sign. And now let's use Doppler formula, where we have to use time t prime, not time t. In that case, this Doppler formula look like this. We have zero speed of observer. It means that on the numerator we have only speed of sound, and denominator we have speed of sound minus speed of our source, in which it was time t prime. So that will be g t prime, speed of this source. And now we can put this time t prime to this formula, which will give us this expression. Now we have expression for frequency in terms of f0, v sound, gh, and time. And this will be answer for the question A. Second question B. We have to graphically verify results from this table. Best way to do it is to represent this dependency as a linear function. In that case we have to square both parts and reverse them, and we will get this expression. That's a linear function. We have already numbers for frequency. We can put it here, and we have time. So hopefully this function will look like linear function. Let's draw this graph. That will be our table for this graph. We have 1 over f squared, the function of time. And from this graph we can find what is the slope of this graph. That will be negative 1.75, 10 power negative 7 seconds in power negative 1. And after that use this expression to find what is f0, this expression. After when we put numbers, we will get answer 574 Hertz. And the last step to find what is total height for this building, using again this expression. And we have, after that we can find the intercept for this graph from this equation. We can put intercept equal to this expression, and the intercept for this graph equal 3.31 10 power negative 6 seconds square. And after that we can find what is total height. These are our final calculations. We can use this formula to calculate what is total height. That will be 533 meters.